So let's talk more about inequalities. We're going from linear inequalities to absolute value inequalities, which you've seen since Algebra 1, but sometimes people in Algebra 1 and Algebra 2 memorize a sequence of steps rather than really understanding what you're doing. If you understand it, then you don't have a big need anymore to memorize. So let's make sure you understand what this stuff means. Now, in this first absolute value inequality, I'm going to say that you word that as x is greater than or equal to 4 units from 0. So even if you don't write it down, I would like for you to say that in your head when you're working these problems. So if I want to look at the number line, 0 is on the number line here. I can be 4 units from 0 by being 4 units left or right. Since it's greater than or equal to, I make closed instead of open circles. Now, if you'll test each division of the number line now. Let's go from right to left. Right now, I'm sitting to the right of 4 on the number line. So, is 4 more than 4 units from 0? Yes, it is. So, shade that part of the number line. Now, in between -4 and 4, I'll put my pin right there. Between -4 and 4, I might have a number like 2. Is 2 greater than 4 units from 0? No, it's not. Don't shade that section of the number line. The third section of the number line is to the left of -4. Is -4 a number like -6 maybe? Is -6 more than 4 units from 0? Yes, it is. Shade that section of the number line. Now what we can do is create a compound inequality that represents our shaded region. So if I color code on this first one, this shaded piece tells me that x must be to the left of -4. And I'm going to say or, because you can't be to the left of -4 and greater than +4 at the same time. This section of the number line tells me that x must be to the right of +4. Now the reason we go from the absolute value to the compound inequality is, as long as the equation or inequality has absolute value bars, you cannot manipulate or move x's around. If I can get to the compound inequality, I can solve for x in more complex problems. So let's do the same thing on the next one. I read this as x is less than 3 units from 0. When you're dealing with absolute value, you've got to go to the units from 0 part. Okay? So again, I go to the number line. Here's 0. 3 units from 0 could be 3 units to the left or right. Less than means open, not closed circles. And again, if I test my 3 divisions, to the right, right here, to the right of 3 might be 5. Is 5 less than 3 units from 0? No. Don't shade that area. Now, between -3 and 3, I might pick -1. Is -1 less than 3 units from 0? Yes, it is, because 1 unit from 0 is less than 3 units from 0. So shade that whole section. Then pick your third division, maybe down here to the left of -3, I'll pick -7. -7 is 7 units from 0. Is that less than 3 units from 0? No, so don't shade. So now I get only one shaded region, and that one shaded region is a bookended shaded region. So I say that my shaded region, x, is between -3 and +3 in the number line, so -3 is less than x is less than 3. Okay? So you're either going to shade the outside 2 portions like you did in the first example, or the inside 1 portion like you did on the second example. So I'm going to apply that same line of reasoning to these problems. Now your first step is to isolate the chunk. So I'm going to say here, to isolate the chunk, I'm going to add 5. On the second one, to isolate the chunk, I'm going to subtract 7 and then divide by 3. On the third one, I'm going to isolate the chunk. 4 minus 6 is negative 2. Uh-oh, I've got to divide by a negative. Remember, when you divide by a negative, you flip over the inequality, and I get positive 1. Okay? So the second step is to think about what's going on. Now, the first and third ones are normal. Normal ones have a positive number here. Abnormal ones have 0 or a negative number there. So we're going to think about them a little bit differently, okay? But let's look at the normal ones first. Now, on this first one, I'm going to say, well, this means that 3x plus 1 is less than 9 units from 0. So what I wrote in dark blue, you can simply think about. You don't have to actually write it out. But when I look at the number line, what that means is I've got 0 in the middle. I know 9 units from 0 would be at 9 or negative 9. It's less than, not less than or equal to, so open, not closed. And then I'm going to go straight to it. Like, for instance, pick a number between negative 9 and 9, like 4. 4 is 4 units from 0. That is less than 9 units from 0. That means I'm going to shade the whole inside. And you only shade the inside or you shade the two outside regions. So I've just figured out this is a one shade inside problem. Now what I'm going to do from there is say, oh, that means that 3x plus 1 sits between negative 9 and positive 9 on the number line. So that's the way I say that. So I make one inequality. Skip number 2 because it's an unusual one. I'll come back to that. On number 3, I'm going to say this means that x minus 9 is greater than or equal to 1 unit from 0. So what's that look like on the number line? And notice I'm using the number line as a step in my work to help me reason through things rather than using it to demonstrate final answer. We can use graphs for a number of reasons. It doesn't just have to show final answers. It can help you think through steps. So on this one, 1 unit from 0 has to be 1 unit to the left and 1 unit to the right of 0. I've got closed instead of open circles because it's greater than or equal to. Now, this time if I pick the number like a half is not more than 1 unit from 0, so don't shade. Well, if I don't shade the middle, then I am going to shade the exterior portions. Plus, you can say, well, check a number down here like 8. 8 is more than 1 unit from 0. Check a number down here like negative 10. Well, negative 10 is 10 units from 0, and that is more than 1 unit from 0. Now, guys, I have 2 shaded regions, so I have to have 2 inequalities. So I'm going to say, from here, this tells me that my x minus 9 is left of negative 1. Or, all right, because if you've got 2 shaded regions, it's an or problem, not an and problem. This tells me that x minus 9 is to the right of positive 1. That's the hard part. The dark blue part is where people get confused. So all you have to do now is finish the thing. Finishing is the easy part. So if you go back to number 1, subtract 1 from all 3 sides, all 3 parts of the chain. So I'm subtracting 1. Now divide all 3 parts by 3. All right. And then if you can do the interval notation, you could go straight to it and say that's negative 10/3 to 8/3 because it is one shaded region. So it's one bounded inequality. That means it's one bounded interval. A bounded interval means that you don't go to infinity on either the left or the right side. So if it's bounded or it's bookended on the left and the right side. So the same is true for number 3. I'm going to say x is add 9, so 9 minus 1 is 8, or x is greater than or equal to 10. Now, just like the blue graph, it's going to be 2 separate inequalities. So I'm going to say, well, being less than 8 means I'm going to go from negative infinity up to 8 bracket. My or is a union. And then being greater than 10 means I'm going to go from 10 to infinity on my number line. So even if you redrew the graph for the pink answer, the graph would look just like the blue number line. It would just have different numbers on the number line. So if you know what the number line looks like, you know what the number line looks like. You don't have to redraw. Now, what about this oddball one? If it says less than 0, well, what I want you to do is think about it. This side, anything in absolute value is always 0 or positive. Can a 0 or a positive number be less than or equal to 0? Can that happen? Okay. Well, a 0 could be equal to 0. A 0 would not be less than 0. So you could have the absolute value of 2x be exactly equal to 0. But if the absolute value of 2x is positive, that positive value wouldn't be less than 0. It also wouldn't be equal to 0. So my only option is if the left side actually equals 0. Well, guys, the only number I take the absolute value of and get 0 is 0 itself. So if the absolute value of 2x equals 0, that means 2x must equal 0. So x equals 0 is your one and only answer. All right, FYI, if it had said the absolute value of 2x is less than 0, that's never true, because then you would be saying that whatever's on the left side, which is 0 or positive, is less than 0 means is negative, and something that's 0 or positive is never negative. So if I had said the absolute value of 2x is less than 0, you would have said, well, that's never true, so that's no solution. But guys, that red piece at the bottom, that's not what you had. I'm just trying to show you something more. That would have been an easier problem, but you didn't actually have this, so don't get too hung up on it. All right, so let's take a look at a couple more. So on number 4, the chunk is already isolated, so I'm going to skip that step for right now. I do notice, though, this is a 0. If it's 0 or negative, it's some sort of oddball problem, so I'll come back to that. On number 5, I'm going to isolate the chunk. So when I do, the first thing I'm going to do is subtract 9, which is going to give me a negative 4. Now I'm going to multiply both sides by 3 over 2. So that's going to make the 3's cancel and the 2's cancel, so you've got the absolute value of x minus 3. Over here, 2 goes into 4 twice, so that's going to give you negative 2 times 3 is negative 6. Okay? Well, this is also an oddball problem. If you've got a 0 or a negative there, you don't start working it out like I've showed you. These you have to stop and think about. So let's think about both, okay? We know that this side is 0 or positive. Okay? Greater than 0 means is positive. So is the left side, which is always either 0 or positive, ever going to be greater than 0? Well, this is true as long as it's not 0. So the 0 part wouldn't work, but as long as the absolute value of 10 minus x is positive, then it would work. It won't work for 0. Well, the only time that 10 minus x, think about it, if you have the absolute value of 0, that's equal to 0. If you have the absolute value of negative, that's going to equal a positive. If you have the absolute value of a positive, that's going to equal a positive. Well, the only time I'm saying that the inequality is not satisfied is when you've got what's inside the absolute value bars being 0. So if what's inside the absolute value bars is negative, it's going to turn out positive. And if what's inside the absolute value bars is positive, it's going to be positive. So all I have to say is what's inside the absolute value bars can't be negative. Can't be 0, excuse me. It can be positive, it can be negative, and the absolute value will force it positive. So guys, this is a little different. That's just telling you x can't be 10. So if you look at that, on the number line, you're saying It can't be 10, so bubble wrap it, but it can be any other number. So that's what it would look like graphically, and that means negative infinity to negative 10 union 10 to infinity would be an interval solution. So guys, this non-equation and this interval solution, those mean the same thing. The graph also means that same thing. So on the number 5, what I want you to do is say, wait a minute. This side, remember, is either 0 or it's positive when you take its absolute value. When is a 0 or a positive number going to be greater than a negative number? Because it doesn't matter if that's a negative 6, it's a negative 18, it's a negative 9,000, or it's a negative 1/2. Well, I mean, 0 is always greater than a negative, and a positive number is always greater than a negative. So the statement right here is always true. It doesn't matter what you plug in. So if you get something that's always true, just say all real numbers. So again, if you isolate your absolute value bar portion of the problem, and the number on the right-hand side of the inequality is either 0 or negative, don't work it out, think it through. There's not a lot of work to do. All right? If the number on the right side of the inequality is positive, there's work to do. So you need to think it out, or you need to work it out. You can't just think it through. I'm going to pause the video here, and then we'll pick back up.